Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the File Upload Vulnerabilities module, titled Web Shell Upload via Content Type Restriction Bypass. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on File Upload, Vulnerabilities Labs, and select lab number 2 titled Web Shell Upload via Content Type Restriction Bypass. Alright, let's get started. This lab contains a vulnerable image upload function. It attempts to prevent users from uploading unexpected file types but relies on checking user controllable input to verify this. To solve the lab, upload a basic PHP web shell and use it to exfiltrate the contents of the file /home/carlos/secret. Submit this secret using the button provided in the lab banner. You can log into your own account using the following credentials, and we're giving credentials of a regular user account. Okay, so the target goal over here is to exploit the file upload vulnerability so that we could upload a PHP web shell, which will allow us to exfiltrate the contents of the secrets file. All right, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. All right, the first thing we're going to do is log in with the regular user account that we were given. So the password was Peter, hit login. Now notice over here, it gives you the ability to update an email address, and it also gives you the ability to upload your own avatar. Now any upload functionality should be tested for file upload vulnerabilities. So let's say we upload a PHP shell. So we're going to say file, new file, and say test.php. That would be the name of the shell. Hit create file. And in the shell, we're just going to add a bit of code that allows us to run any command that we want. So we'll use the system function to run a command that is taken from a parameter from the client side, so from their GET request. So we'll say from the GET request, get the content of the CMD parameter, and we'll end our PHP script. It's as simple as that. Let's try and upload it. So test.php, hit select and upload. And we get an error saying, sorry, the file type application XPHP is not allowed. Only image JPEG or image PNG are allowed. So let's look at the request in repeater. So it was this request right over here. Let's send it to repeater. Now, if we look over here, you could see it's supposed to request to the /myaccount/avatar endpoint. And for our PHP script, you could see the content type is application/xphp, which the application does not accept. It only accepts this content type and this content type. Now, this is a user controllable input, and so if the application only validates on this input, then we could bypass it by simply setting it to anything that we want. So we'll keep it as a PHP script, but we'll just say, hey, the content type is not really PHP, it's image PNG, and see if the application accepts that. So let's hit send, and it looks like our test.php file has been uploaded. So if we go back over here, and then we right click and open image in new tab, you could see that it is loading our script. Now all we have to do is add our parameter, CMD, which allows us to run any command that we want. So let's say who am I? And you could see the privileges that we're running with is the Carlos user. Let's output the host name of the server that the application is running on. Ooh, that did not work. And that's because I spelled it incorrectly. So let's say host name. And here we go, that's the host name of the server. Now let's output the content of the secret file. So cat home Carlos secret.txt. I believe that was the path. Hit send, and I might have spelled that incorrectly. So let's look over here. So there's no txt, it's just /secret. And And here we go. We get the secret. So let's copy it. Go to Submit Solution. Hit OK. And we get the congratulations, you solved the lab exercise. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. Okay, so before we do that, let's send all the requests that we need to perform in our Python script. So the first one was the login request, which is this one right over here. Let's send that to repeater. And then we uploaded the avatar, which was this one over here. Now in this one, it was a 403 forbidden because the content type was PHP. If we go back to repeater over here, and we look at this request over here, you could see that we changed it to image PNG, and so it worked. So let's call this one login, this one upload avatar, and then we need to retrieve the avatar, which will allow us to execute our script. And that would be this right over here. So let's send that to repeater. And call this execute avatar. All right, so these are the 3 requests that we need to perform in our script. So the first thing we're going to do is upload all the libraries that we're going to need. So import requests, import sys, import URL lib3 from BS4, import beautiful soup, import random string, and from requests toolbelt, import multi-part encoder. So we'll need all these libraries to perform our requests. Next, we're going to disable insecure requests warnings. So URL lib3 .disable warnings, URL lib3 .exceptions .insecure request warning. And then we're going to set our proxy settings so that all of our requests get sent to burp. So all HTTP traffic should be sent to where burp is running, which is 127.0.0.1, port 8080. Same goes for all HTTPS traffic that should be sent to where burp is running, which is 127.0.0.1, port 8080. Next, we call our main method and define it. So if name is equal to main, then call the main method. And the main method we'll define right over here. So def main. If the length of the command line arguments, so sys.argv, is not equal to 2, then print the usage instructions and the example instructions because the user ran the program incorrectly. So the usage instructions, name of the program, and the URL of the application, and the name of the program we take from the command line argument. Same goes for the example instructions. So example, name of the program, and an example URL. So let's say www.example.com, and the name of the program we take from the command line argument. And since the user ran the program incorrectly, we'll exit the program. Now let's assume the user did run it correctly. The first thing that we're going to do is initiate our sessions object. So request.session. And then we're going to create a variable URL, which we take from the command line arguments. And then we're going to call a function exploit file upload, which takes in the session object and the URL. This is a custom function that will perform these 3 requests over here and then output the content of the secret file. So we'll define it right over here, def exploit file upload. It takes in the session object and the URL. Now, if we look at the login request over here, it's a post request to the /login endpoint. It takes in 3 parameters, a CSRF parameter, a username, and a password. Now the CSRF parameter we need to extract from the previous request, which is the /login request. So what we're going to do is we're going to make a comment saying get CSRF token. And to do that, we need to call the login URL. So that would be URL plus the /login endpoint, and the CSRF parameter or the CSRF token is going to be equal to the return value of the function CSRF token that takes in the session object and the login URL. Now, this is a custom function that we'll define ourselves. We could have defined it right over here in this function, but because we'll call this function again when we're performing our upload avatar request, we just implemented it as a function on its own. So we're going to say rest of code here and define our get CSRF token function. So def get CSRF token, which takes in the session object and a URL. To do that, it's simply a get request. So as .get to the URL, we set verify to be equal to false and proxies to be equal to proxies. And then we're going to use the beautiful soup library to parse the response. So r.text is the response, and we're parsing it using the html.parser. So the CSRF parameter or token is going to be equal to soup.find, and we need to find it in the /login request. So if we go to proxy right over here and we look for the get request to log in and we look for CSRF over here, you could see that the CSRF token is an input element that has a name CSRF, which contains the value in the value attribute. So we're going to say look for the input element that has the name CSRF and then extract the content of the value attribute. And that's equal to our CSRF token right over here. So we'll return that. And when we return it, it'll be saved in the parameter CSRF token. All right, so if we go back to our exploit file upload function, let's log in as the user. So let's go back to repeater and perform this request right over here. It's a post request and it takes in a few parameters. So first we're going to print logging in as the user that we were given. And then we're going to create a data login endpoint, which takes in all the parameters of the request. So the first one is the CSRF parameter, which we just extracted right over here, and it's equal to CSRF token. And then it's the username, which is just the username that we were given. And then password, which is just the password that we were given. All right, and then we just perform the request. So we're going to say r is equal to s.post, post because it's a post request. It takes in the login URL. Data is equal to data login, which we just defined. Verify is equal to false because we don't want to verify TLS certificates, and proxies is equal to proxies because we want our request to be sent to burp. And then we're going to confirm if we properly logged in by looking for the string logout in the response. And if we get it, then we'll print successfully logged in as the user that we were given. Otherwise, we'll print could not log in, and we'll exit the program because this is an authenticated vulnerability, and if you can't log in, you can't perform the exploit. All right, let's assume we successfully logged in. The next step is to upload this avatar right over here. So we need to perform this request. So we'll print first uploading web shell. Now in this request over here, it takes in a few parameters. The first one is our PHP script, and then the user and a CSRF token. So the CSRF token over here is going to be different from the one that we extracted before, because this one is taken from this request over here. So the previous request in the referrer header, which is the /myaccount page. So we need to extract it again. So we'll say my account is equal to URL plus /myaccount. And we'll extract the CSRF token from there. So we'll use the function that we created, get CSRF token. We'll give it the my account. Let's call this my account URL. And it takes in the session object as well. All right, so now we've extracted the CSRF token, and now we could just define the rest of our parameters. So we'll say avatar URL is equal to URL plus the link to the request, which is this one over here. Let's paste it in here. And then we need to save the parameters of the request. So we'll save that in a variable called params. The first one over here is our PHP script, which is saved in a parameter called avatar. So we'll put that right over here. And then we'll say that's equal to a file called test.php, which contains the following content. So our web shell, and the content type over here is image PNG, so that we could bypass the content type filtering restriction. And then we just define the rest of the parameters, which is the user parameter, and that's equal to the user that we were given. And then the last one is CSRF, which is equal to the CSRF token that we extracted. All right, this looks good. Now, if we were to perform the post request, it'll appear as regular form parameters. However, this request is in a multi-form format, and so we need it to appear exactly like this, where it has this string right over here and this boundary right over here. Now, the boundary over here is just 16 random alphabets and digits, and so we could generate that ourselves. So to do that, we'll say boundary is equal to this right over here, plus the random string that we want to create. So random dot sample string dot ASCII letters plus string dot digits, and we want 16 characters in that string. And then we'll say M is equal to multi-part encoder, where the fields is equal to params, but we want them in the format where they have that boundary, which is this one right over here. All right, this looks good. Next, we just need to define our headers. So headers is equal to content type m dot content type, and then we just perform the request. So r is equal to s dot post avatar URL, data is equal to m, headers is equal to headers, verify is equal to false because we don't want to verify TLS certificates, and proxies is equal to proxies. All right, so this performs this request over here, which uploads our web shell. Now we need to perform the request that executes our web shell. So we'll first print saying the following is the content of the secret file. And to perform that request, we need the URL to the PHP web shell. So that's URL plus this entire thing over here. So let's copy that, paste it in here. I believe the request URL encodes it, so you don't need to URL encode it yourself. And then we'll say r is equal to s.get cmd URL verify is equal to false, and proxies is equal to proxies. And then we just print the response of the request. And that's essentially it. So let's remove all the unnecessary lines, save it, and hopefully we don't have any errors in the script. So if we go back over here and open a new instance of the lab because it likely timed out, and then we go to terminal, new terminal, Python 3, file upload lab02.py, and then we need the link to the vulnerable application. So let's copy that, paste it in here, remove the trailing slash, and before we run, we're going to look at Burp to see all the requests that the script is making. So let's hit send. We have an error on line number 38. And this should be over here. So this is the value of avatar. So let's save it. Hopefully that's the only error we have. Hit enter, and it's not. And I did this in a hurry, and that's why I have mistakes. So lab number 8, that should be URL lib3. Save it. Let's clear. Hit enter. So far so good. So you can see over here it's logging in, and then it gets the my account page, and then it errors out because it can't find the CSRF token. So we made a mistake in the way we extracted the CSRF token right over here. So if we go to my account and we search for CSRF, CSRF is definitely available over here. And so the mistake must be in the way we're parsing the request. So let's go to line number 35. So when we say get CSRF token, it's to the URL / my account, which looks good. And then we extract it over here. So this all looks good. I'm not sure why you can't find it. I'm just gonna run it again. Maybe the lab hadn't loaded yet. And no, we definitely have an error. So if we get my account over here, and okay, now I know what the issue is. All right, so we're actually calling the wrong URL over here. It should be my account, not my underscore account. So let's save it, clear it, and run it again. So we're logging in, that's successful. And then we're uploading the URL, that was successful. And then we execute our script, and you could see over here, the content of the secret file is outputted for us. All right, let's copy this, submit solution, paste it in here, and hit OK. And you get the congratulations, you solved the lab. Okay, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of a file upload vulnerability.